inverter idle power consumption most times has been neglected during solar sizing, but that could actually draw back the system you feel like you've already sized, because most inverters like 10 kVA inverters could actually take a very big amount of current during the day. So by the time you make your proper calculation, neglecting the solar inverter inputs in terms of idle power consumption, it can actually overwhelm your system. And how can it do that? Taking for instance a system that is consuming about 200 watt of energy per hour. When you multiply 200 watt of energy in 10 hours, it's giving you about 2000 watts. Of course, some system might be drained off. Practically, you can actually do, connect your inverter or connect your batteries, leave it without powering any of the appliances. You find out that before the day goes by, the battery energy have reduced, right? So in this video, we'll make proper calculation on how the inverter idle power consumption affects your system. I have with me a 1 kVA. This is 1 kilowatts. It's about 1250 voltage amperes, but it's rated 1 kilowatt hour. This is a Fairman inverter which we'll use to do the test. I also have this big guy. I don't know how to lift it. This is about 7.5 kVA hybrid Yohako inverter. So you don't expect the idle power consumption of these two systems to be the same. You find that if you are running just like these 4 batteries that I have here, this is about 100 amps battery each. If I do my series connection with the 4 batteries, it could give me a voltage that could power this system. Then if I connect all of them in parallel, of course, one of it can actually power this system. I can choose to connect all the 4 in parallel to also power this system. So what do I gain? If I turn this system on at 0 load, when I say idle power consumption, is the energy the inverter is taking to build up regular 230 or 220 volts, as the case may be. See the inverter idle power consumption as when you turn on your car in the morning, like you want to, run the engine without going anywhere. You find out by the time you turn on your car engine, the car would consume fuel, right? Then if you leave it on for like 4 or 5 hours, you find out that your car might even stop running because the car must have taken all the fuel inside your car, but it didn't go anywhere. So when we do solar sizing, we put all these things into consideration. You have the MOSFET switching, you have the inductances that you have in the inverter. There are some inverters that have transformer like this, although the second one is also a transformer based system. So those hysteric noise you are getting, those are forms of energy transfer. You know that energy cannot be built according to the law of conservation of energy. You cannot create energy, and you cannot also destroy energy, but energy could be transformed from one form to another. So having this in mind, that hysteric noise you are getting from your inverter is just like a sound energy coming from the transformer and some of the components, you have within the system. So it takes up current to run, it takes up voltage to run. So, and as long as voltage and current are into the system, you are dissipating energy, right? So we'll make up a setup. We're going to set our system up, then do the proper calculation, use our multimeter to do the current test. At first, we'll test for the DC, how much energy, how much current the inverter is drawing from the batteries at 0 load. By the time I will do our installation, we on the inverter, we'll now check how much current the multimeter is reading from the battery. That is how much DC current the inverter is taking from the battery. By the time we know that, we'll now add just some small load like fans. I think I will have to bring about 3 fans. We'll on them gradually. So when we turn on the first fan, we know if there is any increase in current, because voltage is almost the same like during the whole process. Now we also check, by the time we turn on the second fan, how much current that will be increased on the DC, right? Now by the time we turn on the third fan, we'll now check if there's any increase in the current. Now by the time we put up our setup, turn the inverter on, we'll now find out that practically there is no current coming out from the battery to the inverter. We can now say, okay, maybe idle power consumption should be neglected. But it's now how much current we are going to get from this process that will make us determine if actually we need to neglect it or put it into consideration during our solar sizing. Again, we'll now check how much current that is coming out from the AC side. Because when we check how much current the inverter has taken to turn on at zero load, we connect one fan, connect two fans, we connect the third fan, we'll now know how much current the inverter drew from the batteries. That aside, we'll now do another experiment to check how much current on the AC that the load is drawing from the inverter. So what I think is that by the time we check the idle current consumption, the only current that should be increasing will be how much current that is going to the appliances. But by the time we will now check on the AC side, we will now try to match it up with how much current we got from the DC. So if there's any increase of the idle power consumption as a result of increase in load, we will know. If there are still load increase, we also know. By the end of the day, we can now do some calculations to know, where we are heading to. So stick with me for now. If this video is interesting you, do like, subscribe, and also share. Because if you have made it this far, which means you are very much interested in what we're about to do. And by sharing this content, it motivates us to, keep on doing similar things that you would enjoy. And by the time you subscribe, videos like this and more better ones will be coming your way.